I'm David D. Hilster, and I'll be talking about deploying digital human readers leveraging HPCC Systems. As you know, HPCC Systems processes and retrieves immense amounts of data quickly and efficiently. It allows for plugins to enhance its capabilities. We have some natural language processing machine learning algorithms available. And we do have two functions, NLP functions for ECL called patterns and rules that are also available. But today I'll be talking about an NLP plugin that will allow us to build what I call digital human readers. And of course, the question is, why would we want to do that? Well, the big reason why is the difference between recognition and understanding. Recognition is what machine learning does. It's not understanding. Machine learning is pattern matching and not understanding. Common tasks in machine learning and NLP, for example, are speech recognition, which recognizes words but does not really understand them. Translation, which recognizes patterns between language, but again, does not understand them. Predicting the next words while typing. We're all very familiar with that on our phones. Again, we also know it's not the greatest. And again, that's because it's not understanding what you're typing. And also there is word frequencies and distances that machine learning can get with text vectors, which is a package we have with HPC Systems machine learning bundle. But again, it's statistics and it's not meaning. So today I'm going to be talking about digital human readers, which involve linguistic knowledge with a specific language, world knowledge, and knowledge of a specific task. And that's really what we would call understanding. An in-house example of this is a project that I have been involved with called with radiology reports. And we first tried at the company using machine learning. It was a very small test set because it's HIPAA data, which is personal information. So we can't get lots of data in the beginning, and that's what machine learning really needs. We had a very small number of test cases because they were being built by one doctor, and he wasn't too happy about having to build 200 test cases for a system. And the results were we couldn't get enough samples for training, that we didn't get the desired results we wanted from using machine learning, and the domain experts were not interested in becoming test case generators. And most important, there were things that machine learning simply could never tackle, which was world knowledge, like an appendix and what size is supposed to be. And if the size is being stated by radiologists as, for instance, being 2.7 centimeters, which is not the correct size, then the machine learning algorithm would not know that and not alert the radiologist to that. So I was tasked and have been tasked and been working on creating a digital human reader. And we have a sufficient amount of samples to analyze the reports. I have a master's in linguistics, so I can go through and really look at what's going on. I can interview the domain expert to define if that human being was doing the task, what's involved, investigate what knowledge is needed, and of course, design text analyzers to use that knowledge and write the code. Well, what we use are going to use and have been using is NLP++ and visual text to build these digital human readers. NLP++ is the only computer language specifically for natural language, allows for building digital human readers for specific tasks. It includes a sophisticated pattern matching language for the text and integrated knowledge-based system. And basically anything thinkable. If you can think of it as a human being, you can program it. Visual text is a rapid IDE for creating digital human readers. It is now available and is working quite well in VSCode. VSCode has an NLP language extension, runs on Windows, Linux, and Macs. And of course, I'm talking today about the NLP++ plugin for HPCC Systems, which brings digital human readers to HPCC Systems and takes full advantage of the supercomputing on the cloud and on bare metal arrangements. Here is an example of the ECL code that of calling the digital reader. This one happens to be a diagram parser of all of English. Whatever you throw at it, it's going to build a tree for that. The yellow there is the calls you need, which for the NLP plugin. It's basically 3 lines: import the text itself, and then the analyzer, which comes back with XML. Everything you see in green is just your plain old record structures and XML ECL language for getting the results back into two record structures called vertex and edge. And what you see in blue is the visualization. And what the output you see here is a syntactic parse tree where you have the quick brown fox jumped over the lazy boy. So this is available right now, and it will parse anything you throw at it. But what we're going to talk about today in this talk is a demo digital human reader, which I came up with, I'll tell you why, which is to assign Lex IDs and relationships to people in the Bible. The Bible, of course, is an open source book, so that makes it easy and everybody can use it. Well, the reason I chose this is the ECL class that's being taught, they often use an NLP demo of using the patterns and rules for the begat phrases in the Bible, whereas you have someone begat someone and someone begat someone, and they match this in the Bible text to get out information. And that's very simple NLP processing. What I'm going to do is build a new demo for the NLP++ plugin. And I'm going to create Lex IDs and relationships for people in the Bible. I thought that was funny if you are a person who knows Lex IDs and our system at LexisNexis. And we're going to parse Bible verses into people and relationships and get their names, genders, and parents. Not as easy as you think. This is not a pattern matching problem, a machine learning problem. The Bible is a single text. It's not millions, so we can't throw lots at it. You can only really do corpus studies of works proximities if you only have one corpus. You cannot learn world knowledge, of course, by text alone, can't do that. And the wording in the Bible is a little non-standard, so it's really not a machine learning problem. But if we humans can do it, and if we humans can do it, we can write a digital human reader for that. They know the language. It takes anywhere from 4 years to 14 years to learn a human language. 4, you want to know which languages. 4 is for English, one of the easiest languages, not easiest language in the world to learn. And 14 for a language like Finnish. You can read, humans can read the Bible without having to read other texts to understand it. They know about how the world works and human relationships, and they know how their languages map into the real world. So humans do have an advantage. This is the text. Everything you see in yellow is what our new parser is going to get, and what the other parser, the parser today, won't get. You can see at the bottom there is what it can get, the few begat functions. You can see again some more yellow, and here we have a lot more yellow. But today I'm going to be talking about one sentence, and I'm going to talk about the design, and this is my design because NLP++ is a computer language. If I make this analyzer, someone else could do the same task and build a different analyzer. I'm going to use the full English text that comes with NLP++, which gives you the parts of speech, nouns, verbs, determiners, prepositions, gives you roots so you don't have to worry about conjugations of verbs like was, knowing it's the word a verb to be. It also gives you automatically genders for words like wife being female, and numeric words. So if you say 2 wives, you'll know that's the number 2. And we're going to parse those texts into verses and sentences. Pretty easy to do. We're going to find the names. We're going to find the verbs interested. We're going to read left to right. And I decided to make our reader do left to right and make it a little bit easier for people to see how this is being done. We're going to use world knowledge at the end of this, and to finish up to get the information, we'll output this to a record structure in our HPCC Systems programming. So here's a quick walkthrough of our demo digital human reader. We look up, this is a screenshot from VSCode, from visual text, what I call it. So you're seeing actual code from the computer. This is the output of the first pass of the digital human reader, which breaks down each and looks up each word. You can see here the parts of speech. You can even see down here gender for male for the man. Next thing we do is we break it down into sentences and verbs. You can see this is like nested. Think of this as nested folders on your computer. We do that. We then identify what our names. Again, I'm not going to get into how we do that, but we write code to do that. It's very easy to do. We look at the verbs taken, knew, conceived and bear, was born, begat, you see there, took, bore, like bear, and those things are identified. And we're going to trace through left to right using memory and actions. Again, this is my solution to this problem. We're only going to look at one part of the sentence because we have a short amount of time today, but we are going to parse this entire these two verses of the Bible. But we're going to look at Adam knew his wife. Adam knew Eve, his wife. Come on, Dave, you can read. So we're going to look at the first word up the top there, Adam. And as we read it, our understanding system says, hey, I've come across the name of people. So you can see here, put Adam as a person. In our memory, in our short-term memory, we got Adam as a person. The text is Adam, name, and we got even where it is in the text. We go to the next word, which comes in as new. It's actually the word know, to know. We then build an event where we have Adam is knowing something. He's the subject of this event. We put into our memory that we now have a verb, and we put in an action. And that action says, oh, by the way, we have an event know, we have a subject Adam, but we should be on the lookout for an object. Well, we go to the next word and we get what we want, which is the object. We put that into the memory. This action of expecting an object says, oh, I see an object, I'm expecting an object. It goes in and says, okay, I'm going to go put that object in know. And now our understanding system now knows that Adam knows Eve, and that's an event of knowing. The next thing is a lot more tricky. It seems easy to us, but we get the phrase his wife. His wife gives us the gender of female, that is wife. It's a family as wife. And what gives us a possessive or ownership gender of male, that is his wife. But how do we deal with this? Well, we put that into our memory, first of all. It's a person, this wife. And we have to figure out which person it's referring to. We see we have a refer back to, it goes back and says, oh, this wife is going to be Eve. We're looking for find an adjacent name. That is, when we get his wife, we put this action upon it because it's not a name. It says we're going to look around his wife to find a name. Now we could have said Adam, they could have put in the Bible, Adam knew his wife Eve. Exact same sentence, same meaning. And that's one of the things about humans. We can read different forms and get the same information. So this says, go find an adjacent name, Eve. It does find it. Then when you do it, it's in an object of know. It knows the possessive knowing is going to be the subject Adam. So it's going to say Adam gets the his or male marker, and Eve gets the female marker and is the wife. So this is how the system is reading and understanding. Again, this is just pointing out what the system is doing. And the last thing, of course, we end up, when we parse everything, which we didn't, I'm not showing all that, but for the sake of time, we get Adam and Eve, Cain and Abel. And we have Adam has the spouse, is Eve, his gender is male. We have Eve is a gender female, has two children. The English told us that Eve gave birth to children. Gave birth to Cain and gave birth to Abel. It didn't tell us anything about Adam being involved or those being his children. Well, why is that? Because we have world knowledge as human beings. So I invoked a rule of world knowledge saying a spouse inherits children from a known spouse. That is, one spouse knows another spouse. The result is children. And if you have that, then you see that they're spouses. You can see one here, that these children then get put into also to be included in Adam. And then we have a second rule that says, oh, if a child can inherit a parent from a parent's known spouse, that is, even though we have over here on this side in the beginning, Cain's parents is Eve, we know because they know each other that he's also going to have a parent of Adam, and that Adam, of course, we also had shown in the other rule that fills out the information. So now we have Adam and his Lex ID, his name, his gender, and his children. Eve has the spouse, gender female, and their children. Now we have Cain and have both of their parents and both as Abel. So you can see you can't get that statistically. We have to have knowledge in our system to be able to do that. So here is the calling the analyzer from the ECL. So we have Adam knew Eve, his wife. Again, we call it this time on the Bible analyzer. We put him into two records, which has the name, Lex ID, and gender, and relationship, which relates to Lex IDs and calls a relationship. We put those into the record structures and output them. Again, you can see this is very, very little code in our supercomputer ECL HPCC Systems programming language here. And this is the output. So we get Adam, Eve, Cain, and Abel. They get Lex IDs. So they're in our system forever. We have the male, female, 2 males, and we have the relationships. Lex ID 1, Adam has a child. Lex ID 3 is Cain. Adam has a child 4, which is Abel. He has a spouse number 2, Lex ID 2, and you can see all of that percolating down here. You can see the children here, the 2 children from Eve. You can see that Eve's spouse is number 1, which is Adam, and you can see Cain, which is number 3. His parent is Eve, his parent is Adam, Abel's parent is Eve, and parent is Adam. Again, all figured out. Well, the reason we know we're understanding this is because the system has understanding of the text and the syntax of the text. It understands the text structure of verse numbers and sentences. It understands the capitalizations in English, what would be a name, for example. It also has a knowledge base, has a dictionary of parts of speech and number information like 2 = 2, gender. It has knowledge of verbs. I didn't show this because we don't have enough time to show everything in the short amount of time. And of course, we have knowledge of relationships, which come in this case in the form of rules that we apply in our programming. So the digital human readers, the reality, let's step back. We're done with our demos. The reality of digital human readers is that the tech community at large is really fixated on machine learning, thinking it can do everything, including natural language processing. And they know machine learning really can't produce digital human readers. It can recognize things, but it can't really read and extract using human knowledge to do things. Human readers for extraction really are considered to be impossible to build. Even with our own company, when we tried machine learning with radiology, it just didn't work. They are also unaware of the technology of NLP++ and visual text, which is in VSCode, because it's newly open sourced. It was open sourced just a little over a year ago, and they are looking for turnkey solutions to specific problems which don't exist. So they look at it and they end up punting and saying, okay, we're not going to do it. But those in the know, who know NLP++ and visual text, that allows for creating human digital readers for specific tasks. It is possible to build them, the digital human readers, and digital human readers bring new structured data and revenue to companies. That's a fact. We know that it can open up lots of new data that we can't get a hold of right now. And digital human readers are now part of the HPC systems on the cloud, which of course on the cloud gives us a lot of advantages. So I am today announcing the start of an NLP Center of Excellence. We're going to create, we have created an in-house group whose goal is to develop, build, and maintain digital human readers across the company. And our Relics group is the largest publishing company in the world. One of the reasons when I came to this company about 7 years ago, I knew that. I have this specialty. I said, this is a great place to do this. And we have plenty of experience, of course, with handling text. We have plenty of text to mine. And of course, we have lots of areas, law, medicine, news, and in the future, real estate, which is a multi-billion-dollar endeavor, and data out there, which we could start doing at LexisNexis. Of course, we can open up new sources of text as well, because digital human readers can not only understand text, but they can clean up OCR, whereas trying to write a program to do that is very hard. With NLP++ and visual text and our NLP plugin, we can do that. And that can bring, of course, new data and revenue for a company using the digital readers. And I'm really hoping we have a long-term commitment company-wide to developing these digital human readers, because they do take some time, but they're not simple, but they are doable and very lucrative. So we want to augment digital human readers with machine learning where useful, because we can put them together where useful. Calling all language enthusiasts, that's what I'm doing for all of you people who love language. You don't have to be a programmer. The technology is open source. HPCC Systems NLP++ plugin is open source. The technology, visual text and NLP engines, open source. It's in version 1.7.5. It's written in C++. Anybody contribute if you want. Visual text is a NLP language extension for VSCode. It's already got almost 200 pull requests up to version 1.10. Great, it's the best visual text we've had during the last 20 years. And we have our full English dictionary and parser, which is available to anybody in the world. And I'm looking to perhaps start some intern projects for the first time in our group for NLP in 2022. So if you have some ideas or love this area, I'm hoping to have some projects, or you can suggest a project for us and talk to Lorraine Chapman. We also, again, I'm calling for all language enthusiasts. You don't have to be a programmer to be part of the NLP Center of Excellence. Visual text is used by non-programmers all over the world. We have people using it, and we have programmers alike using it, of course. And both programming and non-programming tasks exist. On my next slide, I'll tell you about some of those. And of course, building digital human readers is really addictive, because it's really, you start to think, how do we do this stuff? And you really get into doing this. And like I said, people who start this really get into it. And next thing you know, they're really having a great time at it. So we are all experts, at least at one human language. And that's why anybody can do this and contribute if they love language. In-house group I've started is an internal in-house group and on our SharePoint sites called og.nlp. So if you want to join in, that's where we're going to be doing our work and communicating. And we also have several internal projects already started and have great interest here at LexisNexis and Relics. This is our current work and future work for the NLP Center of Excellence. Parsing, we want to break down the full English parser into chunks and more useful things like syntactic phrases and numbers and monies, dates, emails, those kinds of things. Addresses, another one, so we can grab those and use them. Anybody can grab those and use them. We want to develop full syntactic parsers for non-English languages like Portuguese, Spanish, Chinese. We want to develop template starter digital readers, so as we go in our company, we can go and do a new task much quicker because we'll have some type of template going. We also want to develop document ingestion analyzers for OCR correction, pre-processing incoming data. For instance, real estate documents come in all kinds of forms, resumes, those kinds of things. And we can, of course, include these new text sources for ingestion and reading to tap into new data and revenue. And as for other tasks, we have dictionary knowledge bases we have to build, enhance and update our English dictionary. We want to develop dictionaries for Portuguese, Spanish, and Chinese. Develop dictionaries and knowledge bases for medical, legal, business, real estate, etc. And we use NLP++ and visual text to build dictionaries and knowledge bases that we use with the digital readers. So it's a bootstrapping system. So I hope that your interest has been piqued about what human digital readers are, and the NLP++ plugin for HPCC Systems group. And if you are interested, you can contact me, David D. Hilster, at david.dhilster@LexisNexisRisk.com, and I'd be happy to talk with you about digital human readers. Thank you so much.